Yes! Oh, you guys don't know how excited I am! Welcome to the first episode of the series. We're going to be covering vectors today, but before we do that, I just want to wish everyone a really great day. You delicious people deserve everything. You guys deserve happiness and fulfillment. So I really hope you guys have your source of enrichment that can get you there because you guys all deserve it. With that being said, let's get into the topic. Let me preface this really quickly. A vector is just an arrow that points in a certain direction. It's really vital in mathematics for the application of physics because knowing how the arrows point and work dictates motion and action here in this universe. I've decided to approach this topic more conceptually than mathematically. I feel like there's a lot more power to showing something conceptually because it gives you a bigger picture of what it really represents. So with that being said, let's go you guys, let's get some physics done. Let's go to the whiteboard, follow me. So if you have wind pushing in the eastern direction, I'm going to draw a vector because that vector indicates that the boat is being pushed in that direction thanks to the wind. Now, if we have another vector, but now it's pushing in the north direction, we have this situation. Excuse the markers. Now, the idea behind this really terrible drawing is that you have two independent wind directions that are pushing this boat. Here's the kicker. Independently, they each push it in a certain direction. What if, take a look, if the two wind directions hit the boat at the same time, what would happen then? You don't feel each independent vector acting on it. What you feel is just one force, and that force is right here. This is what you get. This new vector is what you feel pushing on you. You don't get the feel of the separate vectors, but instead you get an addition of two vectors. That is essentially what adding vectors is all about. Now we're getting into the key points of vectors. As you can tell, these two different directions made it feel like there was only one force acting on the boat. And that's because the two vectors added together gave us this diagonal vector. This diagonal vector is known as the resultant vector, kind of like result, what you end up getting from an addition of two vectors. So that's key. What you might notice is that the resultant vector always makes a right triangle with its components. And this is crucial because when you want to find the components for any vector, just make a right triangle and you have your answer. If per se I give you another vector that is pointing in this direction, I need to break it into its components. Let's just make a right triangle. There we go. Right triangle, voila. We found the two vectors that make up this resultant vector. Okay, so here comes the really fun part. We have two vectors and we need to add them together. Let's do what we've learned so far. We're going to make a right triangle with each vector. You cannot add the resultant vectors directly. You have to do it indirectly through the components. Okay, so the next step in this problem is to do a little bit of that dance. Woo, yeah. No, I'm kidding, it's not. What we need to do is label this just so we don't forget what vector is which. So, the ones horizontally, we're going to call that the x vectors. And don't forget to put a little arrow on top of the v just to indicate that it is a vector. And this is going to be vx1. This one is going to be vx2. Using that same format, we're going to label the ones on the y-axis. vy1, vy2. And then essentially we can label these as the big V's. Oh, again, I have the worst luck with black markers. They just keep running out on me. Oh, so much better. This is big V, 1, and this is big V, 2. Did you notice a mistake that I made in this? I knew you would know. I forgot to put the arrow on top of the vector to indicate that these are vectors. Now with everything labeled, I need to explain how you add vectors, how you move them around and connect them. It's like Legos. Think about it like that. What you need to do is, if you have an arrow like this, you cannot attach one like that, because this is the tail and this is the head. Those are the terms for the vectors. And if tail with tail touch, that does not work. If head with head touch, same thing, doesn't work. You can only have tail and head touching each other. For example, let me erase this. If I have a vector pointing this way, and if I have another vector like this, that is legal. You can do that. But you cannot do this, because now you have the head and the head touching. That's not right. So let's get to it. We got this. We're so close to the end. You guys, just keep up. Now we're going to add the x components together. But if you notice something, they're pointing in opposite directions. So how do you connect them? Do you connect this vector and then this one like this? Or do you connect this one and you put this one on this other end? So for both cases, this is incorrect, because as you notice, the tails are touching, the heads are touching, and you just can't have that. The rule for adding vectors, you have this vector, and we're going to add this one right here, where you just move it there. The reason why you place it there, and I'm going to use black just to distinguish the two vectors, is because the tail is touching with the head, and that works. The other examples were not proper. What you see now is you have a little bit of leftover vector, and this leftover vector was pointing in the positive direction. So at the end, you're left with one vector that is pushing there. So what you did is you subtracted this from that vector, this one being a lot bigger than this one, slight amount, and you ended up with that. So now having this vector, let me erase this. And now we need to plug in the y component, not the x, the y component vectors. This was a lot easier because they're both pointing in the same direction, so they're just adding each other. Let's start with this one. And why do I add it here? Why do I not add it to this side? What makes that wrong? And the answer is because the tails are touching. You can't have that. So I know I've been beating this concept down a lot, but it's just something crucial that even I make mistakes on. So just having that solidified will definitely help all of us just not make these mistakes and be so proficient. Yeah. So the vector goes here. And we bring this one here, same direction, same magnitude. Let's get our black marker and draw the resultant vector. From here to here we connect. Woo! These markers, the black ones, just hate me. So why is this really important? Why do we need to break vectors into their components to find this resultant vector? Why can't we just get this one and put it here and give us the same vector? Essentially, if you get this one and then you connect this one here, you're going to get the same vector right here. The same vector, same magnitude, direction. Why do we need to break vectors into their components? And this is what really gets me, like the beauty of math. The reason why we break vectors into their components is because we don't want to end up with something that's not a right triangle. We don't really have any formulations to solve for an unknown value that on something that isn't a right triangle. But look, when we break a vector into components, everything is just laid out perfectly into a right triangle. You have the x and the y-axis, which always gives you a 90-degree angle. And the resultant vector is just a diagonal that connects from here to this other end. And that's a right triangle. The beauty with the right triangle is that there is something called the Pythagorean theorem. That indicates for all right triangles, you can't forget that symbol for the right angle. If this is side A, so this is side A, this is side B, and this is side C, there is an equation to solve one of the unknowns. A squared plus B squared equals C squared. This equation is so freaking powerful because if you know any two of the sides, you can solve for the third, and it works 100% of the time. It's just mathematically correct. You will have the values for the vector components. You will have the magnitude for x and the magnitude for y. And now it's just straightforward, plugging this into the equation to solve for the hypotenuse. So x will replace a, x squared. B squared will be replaced by y, y squared. That's all going to be equal to the hypotenuse, which is going to be denoted by h squared. Now we need to get rid of the square, so we square root both sides. And that cancels out, so we're left with h. And on this side, we're left with the square root of x squared plus y squared. And just plugging in your values into the calculator will give you h. And so there you have it, everyone. Yes! You've obtained h, which h is the addition of these two vectors, big V1 and big V2. It took a few steps having to get these vectors to subtract, getting the y1s to combine, to add, and then making sure you're following the rules of the arrows. You can't touch tail with tail or head with head. Once you get that situation figured out, you will have a right triangle, and that's going to lead you to find what the resultant vector is. And because you will know what the values are of the x and y component, you can plug it into the Pythagorean theorem and get your hypotenuse, and you're done, and you're done. Yes! Woo! So there you have it, you delicious people. You walked the line. You walked through figuring out how to break vector into components and how to figure out the addition of those vectors. That is key. And in between, you were able to understand certain properties of vectors, how you can add them, how you can not add them, and then understanding that there is a Pythagorean theorem, which is essential to figuring out what the hypotenuse is going to be, finding out the magnitude of the hypotenuse. And it's all a process which is not too complicated, step by step. And that's the only way in life you can take things step by step. You don't want to look at the whole thing together. That's going to become super overwhelming. You want to look at everything on its own, one step at a time, one step at a time. That's how you take life. Whenever it gets hard, just focus doing one thing at a time, taking one step, then the other, and you will not forget that doing this will help you make life happen. Doing this will help you accomplish anything. And I'm being serious about this. Don't overwhelm yourself. Just take life step by step. You can relate math to life because in math, you need to take everything step by step. With physics, the same. With life, just don't overwhelm yourself, people. Please take it step by step, and you're gonna realize that you've accomplished so much when you look back into it. I really can't express enough how grateful I am that you stayed through this whole video. So thank you so much for watching, and I hope you guys learned something and enjoyed the simplicity and beauty of physics. Anything is simple if you take it step by step, always.